Hello, chemistry. We are going to take a look at the questions on your exit slips. So I grouped a couple of questions together that are all related to the PV equals nRT questions. We have two here that relate temperature and pressure. We have one that asks about the gas particles and how they can be added to a container that doesn't change volume. That should have been a V. Here, V, yay. And how are volume and pressure related? I'm going to do one slide on this, a second slide on this question, and a third slide on this question. These are all related to how this equation works right here that we'll be using for the rest of the week. Yay, keep watching. Next up, how does heat create pressure and how does cold affect pressure? So first off, I want to talk, both of these are related to temperature. And we introduced the idea that temperature, in terms of science, is really the speed of the particles. So the faster particles are moving, the hotter something will feel. So if I have something cold, that just means that my particles are moving slowly. So at the temperature that we would call 0 degrees Kelvin, that's where all of my particles would be holding completely still. Now, as things warm up, particles are going to start moving slowly. Okay? As slow particles are going to make fewer impacts. Whereas if I speed up, I'm going to bump against the side of my container a lot more often than if I'm cold and slow. Why do the impacts of the container matter? Because more impacts means more force, because there are a greater number of impacts, which means higher pressure. The other thing we can consider is faster impacts. That's an E. Also results in more force per impact, which also means higher pressure. Both of these come from heat. The faster and with more energy that a particle is moving, the higher force it's going to exert, and therefore the higher pressure you're going to have. So, to summarize, temperature is the speed of the particle. Temperature is really the average speed of all of the particles. Pressure is the average force of all of the impacts of those particles on the outside of the container. Thus, if we have more speed, that results in more and higher force impacts, which means higher pressure. Next up, we're going to talk about how we can increase the number of impacts by adding more particles. Next question. How are more gas particles added to a container? I think this refers to the non-flexible container, because when we think about balloons, usually you think about it, okay, there's the balloon, and then I blow some more air into it, and it gets bigger. So you're used to thinking if there's more air, the container itself is going to increase in size. But we looked at containers that didn't have this ability to increase in size. So let's think about this. If we have particles, okay, they're bouncing around, and all I have to do to add more particles is to just push them in through some sort of opening and then seal off the opening. And normally, this would result in the container enlarging, but the reality here is that it just becomes essentially more dense. And that density can affect other factors like pressure and temperature. But as I add particles, I'm just taking up more, the particles are going to be closer together as I add more, rather than pushing out and creating a larger volume, which is, I think, what some of you expected to happen, but will not happen if you have a rigid container. Overall, we have more particles added, results in them being closer together instead of expanding the volume. Last question. How does volume affect pressure? So this is a case where, unlike before, we can change from a smaller volume to a larger volume. So I'm going to do this example using just, let's put 3 particles in here and 3 particles in this volume. So if you have, let's think about this, if you have like small children, and you put them in a smaller enclosure, the number of times they're going to bump up against the side of that enclosure is going to increase. So we're going to have more impacts. Whereas if you give the toddlers lots of space to move around in, it's going to take them more time to get from one side to the other. And so with a larger volume, you have fewer impacts. So here we have less space between the particles, and here we have more space between the particles. In either case, we're going to have a higher pressure when you're getting more impacts and a lower pressure when you're getting fewer impacts. So if I were able to take this circle here and expand it, see, take this and expand it, suddenly those 3 particles that would be inside of it are much farther apart. So by increasing volume, we are decreasing the number of impacts because there's more space and therefore decreasing pressure. Final summary. So I'm going to talk in relationship to pressure since that's what we studied. So if I increase volume, pressure will go down because there's more space for particles to move. If I increase number of particles or moles, then I'm going to also increase pressure. That's because when you have more particles, there's less space in between them, and they're going to make more impacts. This right here is a constant, so we're not going to worry about that right now. That's just a number to make the equation work mathematically. Now here's the temperature. If I increase temperature, this is also going to increase the pressure, because the particles will be moving faster, and so not only will they make more impacts, they will make higher energy impacts. I want you to notice that the volume is inversely related to pressure, whereas everything on this side of the equation is directly related to pressure. So when this goes up, pressure goes up. And that concludes your answer. Yay! Bye.